One last winter surprise? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 30th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a comment or question, write it up down below. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Peter Belden, Our Predicament, Coach Nate, Tim Caston, Clay Goose. These are all longtime contributors. I really appreciate it. With that, let's get to work. We'll start by looking at significant wave heights for the entire planet. Starting in the North Pacific, there is a gale producing 22-foot seas northwest of Hawaii, but that's all aimed off to the east. Another little gale trying to organize off the California coast is associated with a developing weather system there. South Pacific, there is a gale south of New Zealand producing 35-foot seas or so aimed off to the northeast, offering some hope for the future. In the North Atlantic, there's a gale. I think it has nearly 40-foot seas south of Greenland. This is tracking off to the northeast, targeting Ireland and to some degree Europe. In the South Atlantic, a small gale with 21-foot seas south of Africa. And then over in the Indian Ocean, a tropical system, another gale with 26-foot seas, and another gale with 28-foot seas. Just looking at the distribution right now, it appears that the North Pacific, or the Northern Hemisphere, is still doing pretty well, but the Southern Hemisphere is starting to wake up as well. But before we get into all that, let's go take a look at current conditions. We're going to start up in the Pacific Northwest off the Columbia River there on the border between Oregon and Washington. We're going to look at the buoys. The Grays Harbor buoy, number 036. We're looking at all the energy that's hitting this buoy all the way up from 33.3 second period, very high energy, wave energy, if there were any. There is none, 0.0 feet, the whole way down to pure just wind chop, 5 second period, unrideable chop. This is the height in feet of the energy, or the waves, if you will, in each of the period bands. A collection of period bands, like right there, would be what would constitute a swell. So some sort of 8.3 foot or 8.3 second period wind swell maybe in that area. You see there's a little something out here at 18 seconds, not a little bump at 13 seconds. We have an algorithm that goes sort of tries to tease that out. Let's see how well it does. Primary swell, this is the law. If you take the height and the period and integrate them and calculate it will calculate the theoretical height, surf height. Okay, so this is the largest swell in terms of surf height, 2.2 feet at 8.4 seconds. That would be 2-foot surf from 264 degrees, and that's about right. It's really flat up there. And the secondary energy, 0.8 of a foot at 16.4 seconds from 241 degrees, and that's 1.3 feet. And let's go down a little further south. Point Reyes buoy off of Point Reyes, California, just north of the Golden Gate there. Same deal. Much different setup here, though. Low pressure developing off the coast. You see this big spike of energy. Still wind swell at about 7.7 or 8 seconds, filling up the whole lower part of the chart. And then some sort of bump out here at 16.7 seconds. So primary swell, 9.6 feet at 7.8 seconds from 179 degrees. So just south wind chop, theoretically making surf at 7.5 feet. Then that secondary swell, 1.4 feet at 16.8 seconds from 182 degrees, making surf at 2.4 feet, but that is probably all buried under this larger wind swell. And then you can use the chop height here. This is all the energy between 2 and 5 seconds to just give you a general idea of the conditions. The lower the value, I mean, it says 3.6 feet, but really, if you're above about 2.2 feet, things are pretty ugly. 3.6 feet, yeah, it's just a tortured mess. You really want it about 2 feet or less, even 1.5 feet or less for good clean surf. Then we go down to Southern California. Point Loma South Buoy off of San Diego there, number 191. These are all seeded buoys. They're a lot more sensitive than the NOAA buoys. That's why I tend to like to use them. Okay, again, the same sort of not the profile. The wind chop is not there. Why is that? Because the front isn't down there creating a whole bunch of wind and stuff. But we do have that bump here at 15.4 seconds. And then a little bit more energy further out there. Let's see how the algorithm does. Primary swell 2.3 feet at 15.6 seconds from 200 degrees, so some sort of southern hemi swell, making surf 3.6 feet. And then secondary swell 2.1 feet at 12 seconds from 271 degrees. Another little bit of energy at 2.5 feet. And the chop height, 1.8 feet, so much cleaner. Then finally over to the north shore of Oahu, the Waimea Bay Buoy number 106. We see not a whole lot going on. Some sort of, I'll call it wind swell. Pretty much anything less than 13 seconds I call wind swell. Unless you're on the East Coast, like Florida, East Coast of the U.S., then 10 feet or 10 seconds or better is swell. Okay, so we have 1.9 feet of energy at 11.8 seconds, plus a bunch of stuff on either side of the shoulder there. Let's see how the algorithm does. 3 feet at 11.8 seconds from 19 degrees. It's like a southern hemiswell, it seems like. Surf, 3.6 feet, and no secondary swell at all. And chop height, 0.8 feet, so probably pretty clean. All right, so what has gone on across the entire planet over the past week? And we're just looking at significant wave heights. And we're kind of trying to get a sense of, well, is the northern hemi still active? The southern hemi still active? Which oceans are doing the best? Just sort of a general balance of power across the planet. So here we are, Sunday, May 23rd, when we did last week's video a week ago. Put this into motion. First thing that catches my eye, southern hemi seems more active than the northern hemi. Up until about Wednesday, the 26th of March, we did have a gale off of California with 30-foot seas, and that did create a bunch of raw wind swell. You can see some of the power lines videos and see some of the limited raw tow action at Mavericks. But that was sort of short-lived, and whoop, that got us the whole way through the week. And then the North Atlantic kind of came online, and something started developing under Australia. All right, so let's go do a deep dive now. We'll start in the North Pacific. This is remnants of a gale that was actually much stronger over the dateline. We're on Sunday, March 23rd. This actually produced sizable swell into Hawaii. There were waves at Waimea Bay. It also produced swell that pushed into Mavericks. I mean, bare minimal sort of swell, but whatever, it was surf this time of year. You take what you can get. After that, we're into, here comes on Wednesday, the 26th of March, gale developed off the California coast, created some weather as well, kind of a blown out mess. Seas in the 30, well, actually, let's go back because there we go. Right there, max significant wave height, 32-foot seas, and there's the coordinates, and the max winds were 46 knots at basically the same location. So you can sort of get an idea of what was going on there and what created those seas. Now we're into Friday, Saturday, and current state, whoops, actually went too far, there we go. Little gale right off, trying to organize off of Central California. And then another low here over towards the dateline. But if you look at the arrows, it's all pushing off. So there's low pressure here, probably high pressure. Look at dead there. Probably high pressure there, creating a gradient, creating east winds targeting Hawaii, but nothing or targeting Japan, but nothing targeting Hawaii. Then we go down to the southern hemi. We are at Sunday, the 23rd of March, a week ago. Yes, we should go back and look at. So for our friends in Chile and Peru, there was a gale with, let's see how far back I can go here, that produced 37-foot seas, 38-foot seas. So sideband energy pushed up into Chile and maybe Peru, but that was a week ago. That swell is long gone by now. Another gale developed here with 25-foot seas, again targeting mainly South America, not big enough to do anything to reach up into the northern hemi. Another gale pushed under New Zealand, and we're into Thursday, Friday, Saturday, the 29th of March, and then here we are current time, a new gale starting to develop due south of New Zealand. In the North Atlantic, you see that still that pattern of low pressures pushing off to the northeast towards Iceland, but not nearly as pronounced as it was a month ago. Here we are into Thursday, Friday, 20-foot seas off of Ireland. And let's see how we got into Saturday. Another gale, then there's something significant, 40-foot seas. That's as of pretty much right now. It was actually Saturday night. So again, producing more swell up into this area, but that cutoff low that previously was targeting Morocco in that area seems to have abated. In the South Atlantic, there's that same low that pushed south of Chile. It sort of tried to make its way into the South Atlantic, producing seas there in the 20, well, we'll go back. I think we got like 26-foot seas right there. So that energy, where are we? We're as of Saturday. You can see here's the front from it, poised just about now to be pushing into South Africa. That'd be Southwest Africa, and remnant energy pushing south of the tip of Africa. And then in the Indian Ocean a week ago, kind of a pretty calm pattern, really, going into Wednesday. Tropical low out in the middle of the Indian Ocean, pushing off to the west. We're into Friday. Low pressure developed 34-foot seas south of southwestern Australia, but most energy aimed more towards Antarctica than up north, so probably no swell expected from that. And then that's the end of that run. So all in all, sort of a mixed pattern, nothing really standing out. Northern Hemi appears to be fading. Southern Hemi trying to come online, but not quite there yet. All right, so let's go do a deep dive into the North Pacific. We switch at some point here when the Southern Hemi really comes online, then we'll do the drill down into the Southern Hemi. But the North Pacific, having to do with the title of the video, one last winter surprise. We'll talk about that in a second, but we're focusing still on the Northern Hemi for right now. So we're looking at the Jetstream. These are Jetstream level winds up about 30,000 feet. These winds help support the formation of gales and help direct their track. We're looking for a trough, a dip in the jet to the south. We see that right here. And why are we concerned about that? Well, when the jet falls south, it creates what's known as a trough, and that helps create a counterclockwise flow aloft and down at the ocean's surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. As winds get traction on the ocean's surface, creates seas. As the seas radiate away from the fetch area, the lesser period elements decay away, exposing swell. And swell, when it hits your beach, creates surf. And that's kind of why we're here talking about this. We're trying to find any hint for surf production. All right. But let's go zoom out, look at the big picture here. The jet is pushing off Japan, but then heavily splitting with most of the energy in the northern branch, pushing way north of even the Bering Sea, just like into no man's land. Then finally, miraculously on Sunday here, it falls south over the Gulf of Alaska, meets up with the southern branch right here, and then that consolidated flow is pushing into Central California, the San Francisco Bay Area, and that's what is supporting low pressure out here in the Gulf of Alaska. We'll put this into motion. That same pattern continues into Monday. You notice the jet actually getting stronger, dipping further, sort of creating another trough or the same trough pushing inland on, I'll call it Tuesday morning. But look at the jet. Way up into Alaska, does this full backdoor trough thing the whole way out to the date line, and then the whole way into, at this point, solidly Central California. And the trough itself getting squeezed, and there you go, full backdoor trough on Tuesday night, pushing down the U.S. West Coast and inland. Now, the interesting thing about all this is this is kind of a high amplitude pattern. Here you go, as we get into Thursday, the 3rd of April, the jet kind of gets more organized and starts digging out a much more classic kind of a trough. I mean, you can literally see the circulation trying to organize here. Hawaii's right here. This just looks like perfect setup for fetch aimed at the Hawaiian Islands on Thursday. There you go. There's really a quite nice trough as we get into Friday night and Saturday, the 5th of April. And that continues into Sunday, then starts pinching off. And there we are a week out. Now, at that point in time, the jet, a little bit more consolidated, looking a little bit better. Let's just go the whole way through. From there, how do you go from there to that? And how do you explain that? And I explain it through the MJO, and we'll talk about that a little bit later in the forecast. But the active phase of the the inactive phase steals energy from the jet. You get this very split pattern. Then as the active phase builds in, then the jet gets more energy and becomes more consolidated. Now the problem is we're fighting the seasons, right? It is we're transitioning. We're in spring right now. So though the MJO might be feeding the jet, it's also fighting the seasons. All right, so let's go take a look down at the surface. Surface level wind, surface level pressure. It takes wind blowing on the ocean surface to create seas and ultimately resulting in swell. So that's what this is. We see weak low pressure developing off of California right there. I mean, with 25, maybe 30 knot west winds out at sea. And then here's that cutoff low off northwest of Hawaii, producing 35 knot winds, but they're all aimed off in that direction. High pressure there to the north. So you have high pressure, low pressure. Low pressure circulates counterclockwise. High pressure clockwise, that produces a gradient, tightens up the isobars between the two, and that produces wind. All right, let's put this into motion, see what's going to happen in the future. Here comes our low pressure, still developing off the California coast. The cutoff low continues. Low pressure pushes into mostly North California as we get into Tuesday and onshore. High pressure seeping down, and here comes the springtime northwest winds raking the entire U.S. West Coast. Low pressure north of Hawaii, creating some degree of south winds on Wednesday. We'll get into that, the details of local winds. Fortunately, northwest winds fading some on Thursday. Then remember the Jetstream starts digging out a trough. Here you go, 40 knot northwest winds targeting Hawaii perfectly, building to 45 knots early Friday, pretty much the whole way through the day. Targeting Hawaii, Hawaii, theoretically, if this materializes, could get some solid late season swell. That is the surprise we were talking about. Again, it's only on the models. We're 168 hours out. And then on Sunday, it fades. Light wind regime for the U.S. West Coast. Typical springtime high pressure setting up with trades for the Hawaiian Islands. What effect are those winds going to have on the ocean surface? We need seas. That's what we're looking for to get swell. Well, off the U.S. West Coast, nothing. We do see 24-foot seas here, right there, 24.7 feet. The highest seas over this entire domain, but again, not aimed at Hawaii or California. Pretty weak pattern. Then we get some 18, 19-foot seas. There you go, barely 20 feet off of California on Monday, the 31st of March, and pushing onshore. So, and seeing how it's so close to the coast, it's going to be pretty raw and pretty ugly. So, probably nothing great in terms of surf. But then as we get into Thursday, low pressure developing north of the Hawaiian Islands, seas quickly building to 23 feet, to 27 feet, to 32 feet. This is Friday at 12Z, so Hawaiian time, just off the top of my head, at 3 a.m. in the morning, something like that. Building to 34 feet and holding pretty much through the day, aimed directly at Hawaii. You see the leading edge of that raw swell state starting to hit the Hawaiian Islands on Saturday. Now, will any of that reach the U.S. West Coast? you can kind of see before the model ran out there that yes, something, but I think the lion's share of the energy plowing into Hawaii on Sunday. This is, let's see if I can actually tease out what that is. That's like 15-foot seas hitting Hawaii directly. Now, will it be clean or not? We'll have to go look at the local wind model to see. All right, so let's go take a look at the South Pacific. There is a gale developing south of New Zealand with 34-foot seas aimed off to the north. Notice the ice line significantly retreated, pretty normal for this time of year. It is just past, 3 months past the peak of summer in the southern hemi. This is good for storm production because if you get lows, you don't have ice. You need ice-free waters for the wind to get traction on the ocean surface. So pretty good setup for right now. As we get further into today's seas, 33 feet, lifting off to the northeast. There's this little cutoff low or whatever you want to call it with 28-foot seas in the northern reaches of the South Pacific. Don't know that any swell will result from that, though. Moving on into Tuesday, Wednesday, and Thursday. Now, on Thursday, some sort of a broad, ill-formed low-pressure system starts developing in the Southeast Pacific with 26-foot seas, building to 27, 29 feet Thursday night, the 3rd of April, continuing into about Friday morning. That certainly would be enough to produce like a 15, 16 period swell, pushing north, targeting its, well, so Hawaii's at 158 west. This is all well east of there. So this would be mainly a California event, and then certainly down into Mexico, Central America, and South America for sure. And then fading from there, Southern California at 118, 117 west. So the storm as it fades, or gale, still producing swell. And mainly now, actually, this is some new secondary energy on Sunday, a week from now, 29-foot seas. But this looks to be targeting, it's pretty much east of the Southern California cutoff swell window. This looks to be targeting certainly South America up into Central America if it forms. It's a week out. Don't trust a model more than about 3 days out, much less a week. Next, we go to the North Atlantic. We do have our gale with 40-foot seas up there, rapidly targeting Iceland. Swell again for this area of Europe, but that's probably about it. After that, here's that little trough again, trying to set up off of Morocco, producing, we'll call it 18 to 20-foot seas. This is Wednesday into Thursday, the 3rd of April, so local swell, we'll say, even into Portugal, and probably pretty raw and windy at that. Things probably settling down given the time of year. And then we go, yet another system with, what was that, 20-something, 26-foot? No, that's 23-foot seas. So maybe some hope there. And actually more activity beyond that. So North Atlantic not done yet, again targeting Morocco up into Europe. South Atlantic looking for some hope for South Africa. We are into Tuesday, Wednesday. Here comes a gale with 35-foot seas, mainly pushing off to the east, but sideband energy likely for South Africa. This is Wednesday into Thursday. We're at Friday now. You can see actually the energy starting to push there towards the coast. And then after that, stronger system develops actually. There we go. Let's look at that. That was on Saturday with 41-foot seas, again, mainly aimed off to the east, if not southeast. Sideband energy, you can see it right there, targeting South Africa, and we are, we're a week out. Maybe a glancing low of energy from that if the system forms. And then finally, the Indian Ocean, tropical activity here in the central part, some sort of gale with 28-foot seas or so south of Australia and fading out. Now, here's a nice one. Not that it's big, 30-foot seas, but it's aimed off to the northeast, certainly targeting western and southern Australia. And maybe, there you go, you see it, some sideband energy pushing up towards Bali and the Mentawai Islands with luck. After that, things settle down. Let's see if there's anything else on the charts. There we go. One popping up that way, 27-foot seas targeting South Australia. And again, this system here under Africa, is it going to make any eastward progress? Well, it's way out and the models pretty much run out of time. But you get the sense, 1, 2, 3, southern South Indian Ocean appears to be waking up as the North Hemisphere appears to be going to sleep. Local wind forecast for California and Hawaii. Southern California right there. Central California there. There's the San Francisco Bay Area. And Northern California up in there. Hawaii out here. Hawaii under the influence of light trades. Low pressure building off of California with 30-knot southwest winds off the coast near shore. There we go. That's more like current times. It was nuking full on south wind, big chop first thing this morning, but already that starting to blow through. And you see trades to southeast winds for the Hawaiian Islands on Sunday. As we get into Monday, low pressure starts building off the California coast, some version of south winds from the Golden Gate northward and maybe a light northwest flow. Not trades, but southeast winds for the Hawaiian Islands, 10 knots. Tuesday, here comes the north wind machine as the low pushes in, high pressure builds behind, creates a gradient, and you just see 25, 30-knot northwest winds, but 15 knots for Central California. Southern California also getting in on the action with 20 to 25-knot northwest winds. That should probably drop water temperatures. Again, they were starting to rebound from the last northwest blow. Unfortunately, that will be a thing of the past. Southeast winds, 15 knots for the Hawaiian Islands. Wednesday, the wind machine continues. Yes, you'll get wind swell from that, but it's just going to be an ugly, tattered mess most places. Southeast winds again for the Hawaiian Islands. Thursday, winds finally start fading for California. Low pressure builds north of the Hawaiian Islands. Would be nice to have some trades or maybe light southeast winds. That appears to be the case on Thursday. Friday, light northwest flow for California, 15 knots. Some sort of a light southerly flow for the Hawaiian Islands. Saturday, low continues. Look at this, north winds for Kauai. Maybe for Oahu, hard to tell, right on the borderline there. Some sort of northwesterly flow, 10 to 15 knots for California. And then you get into Sunday and strong northwest winds nuking into Hawaii at 20-plus knots. Light wind regime for California. And there we are at 180 hours out. Let's go take a look at precipitation. We're focusing on California here. Rain and snow for California. Sunday, 12Z, that's 5 a.m. You see rain from Point Conception northward. Snow, pretty isolated. Here we go. This is about current time right now. You see snow starting to build over the Sierra as the front pushes in. By Sunday evening, snow mainly for the higher elevations. Rain starts fading for California, mainly from Point Conception northward. Another push comes in on Monday. I mean, for the most part, this is going to be like scattered showers, but you do see showers down into almost San Diego. Snow for the Sierra, focused really on Tahoe on Monday, making it down to Mammoth, but rain mainly from Monterey Bay northward. On Tuesday, again, another push, probably colder air being dragged down by high pressure here, and snow, solid for Tahoe. Rain, the showery thing down into Central California on Wednesday, and then Wednesday morning, all that starts fading out. Popcorn, or not popcorn showers, just scattered snow showers for the Sierra. Thursday, things really clear out, and after that, high pressure sets in. The thought is this is probably going to be the last decent snow event for the season for the Sierra, and rain-wise, I'd put it more for California, even down into Southern California, more like spring showers than any sort of big atmospheric river event. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. This is total accumulated snow at a 12-to-1 ratio. theoretically about 52 inches. Again, you see it all between the 30th and the 1st, maybe the 2nd. So that would be what, like Wednesday sort of thing. And after that, no more accumulation. Let's go take a look at 2 other resorts. Kirkwood, same sort of profile, 46 inches, a little bit further south. Really the focus of this looks to be the Tahoe area. And then when you go down to Mammoth, further south and not quite on the crest, sort of over on the east side of the crest of the Sierra, about 15, maybe 16 inches. And then given the time of year, we certainly want to go look at the snow level or the freeze level, all right? How do you read this chart? Well, this is for Palisades, Tahoe, but there's a whole bunch of these for all the major resorts out on stormsurf.com. The black line is the base elevation at Palisades, Tahoe. The blue line here is the summit at 9,000 feet. That'd be the top of the Palisades. Red, if there was precipitation, this is above freezing temperatures. Gray would be sleet. Anywhere from this, officially, this is 34.6 to 32 degrees, but you really can get sleet even up at 36 and 37 inches. The border between the white and the gray is the 32-degree hard freeze line. And 28 degrees, that's really, when you get 28 degrees, that's where you get really good quality light snow. All right, so here we are. What's today? The 30th, right? Yep, the 30th. Sunday the 30th. So freeze level just above the base. This is probably like 34 degrees at the base, or 30, even 33 degrees at Palisades, Tahoe. But as you get into this afternoon, then the 32-degree temperature line falls to 5,500 feet on Monday. And on Tuesday, you're down at 3,500 feet sort of thing and beyond. Now, so that's all great. And the yellow line here, that's where there's potential for precipitation. So all this looks good. Actually, this entire year, I mean, if you go look at the snow, the really good snowpack is 8,000 feet and above. You go below there and it gets meager and more meager until you get down to about 6,000 feet. Now, these past couple of storms, past few weeks, there's been snow down to 3,500 feet, but snow on the ground, and then you get warm 40, 45 degree temperatures, it all melts off pretty quick. The really hard, the consistent snowpack starts somewhere between 5,500 feet and 6,000 feet, something like that. Of depth, there's something down to maybe 5,000 feet. Anyway, as you get into the 4th and beyond, the freeze level up above the summit, up at 9,000 to 10,000 feet, and the expectation is that's probably where we're going to go from here on out. All right, so finally, what's this have to do in terms of surf for a couple of locations? We'll start again up north, the Columbia River area, and off of northern Oregon. We see surf heights pretty small today, building on Monday, local low pressure up to in the 8-foot range, then fading down from there and pretty much staying down below that. Winds not too bad today, blustery up there, 20 knots out of the south, and then offshore on Monday in the 5 to 7 knot range. Then after that, it kind of looks more just like look at that, a lot of offshore winds. Unfortunately, no swell. Swell heights up to 7 feet at 11 seconds, so basically wind swell. And then fading from 3 feet at 7 seconds and 1.5 feet at 7 to 8 seconds sort of thing. Ocean Beach, San Francisco, surf heights 8 feet on Sunday. Yeah, it is that, but it's a blown out mess. You see south winds they were 30 knots earlier, down to 17 knots. After that, things just settle down. No real surf. 2-foot waves sort of thing. Winds continue northwest, 20, 29 knots, 20. It doesn't really settle down to anything decent till a week from now. Swell heights, 8 feet at 10 seconds, 1.7 feet at 15 seconds. There is southern hemiswell buried in there. I'm not even talking about it because it's so buried in chop. Now you see it here, it becomes a bit more exposed, 1.5 feet at 14 seconds on Monday. Another little southern hemi swell shows up 1.2 feet at 16 seconds on Tuesday, and it goes through its life cycle and fades, and then after that, it's pretty much just wind swell. I'm going to go down to San Diego area, surf heights 2.5 feet the whole way through Tuesday, maybe up to 4 feet on Wednesday, and then settling down from there. But you have this problem with wind, unfortunately. Northwest 23, 30 knots on Tuesday into Wednesday, and then things settle down more normal. But let's go look underneath. Swell, 1.8 feet at 15 seconds. That's that southern hemi swell mixing with wind swell, more southern hemi swell background. So 1.4, 1.3 feet at 15 to 16 seconds Tuesday into Wednesday. That fades out. And then after that, 1.3 feet at 14 seconds. So background southern hemi swell is pretty much it. The North Shore of Oahu. All right, we know there is a storm, or at least a strong broad gale north of the Hawaiian Islands. Right now, surf height's 3 feet. I mean, it's just local wind swell sort of thing. But then we get into Saturday, Sunday, theoretically surf heights going up to 20 feet. And what is that? And winds northeast at 25 knots. So probably not great. Let's go look at swell heights. Really nothing going on up to then next weekend, 12.5 feet at 15 to 16 seconds. So if you have some well-protected break, there will be surf, but wind could be an issue. And finally, Bali, surf heights in the 4 foot, just background sort of swell is my guess for right now. Then coming up to the 7 foot range as we get into next weekend. Winds westerly, turning southerly, and then back to westerly, but all in all, not very strong. Swell heights, 3 feet at 12 seconds, 3 feet at 11 seconds. This is Wednesday into Thursday, and then coming up to 4.8 feet at 15 seconds on Saturday into Sunday. So that looks like the prime target there. All right, let's go take a look long term. What's going on with the weather? We're going to focus on the 2 major weather oscillations that affect weather, surf, swell production. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start by focusing on the MJO, the Madden-Julian Oscillation. There are 2 phases, the active phase and the inactive phase. The active phase is our friend. It is like a low-pressure system. The inactive phase, not our friend. It is like a high-pressure system. The MJO, the active phase and the inactive phase, rotate around the planet from west to east on the equator. The active phase on one side of the planet, the inactive phase on the other. When the active phase starts rotating over the equator into the West Pacific, because it is a low pressure system, it takes warm, moist air down at the ocean's surface, lifts it aloft. That energy gets caught by the jet stream. It energizes the jet stream, both in the northern hemi and the southern hemi. A stronger jet stream is better at digging out troughs and creating storms, which create, of course, swell. The inactive phase of the MJO is like a high pressure system. It creates falling air down at the ocean surface, cuts off the flow of energy up into the jet stream. The jet stream gets weak, it splits and does all sorts of strange things like what you saw on the charts just a minute ago. But we think we are moving towards the active phase just because the jet stream looks to be getting more consolidated. Let's see if that is true. We're going to look for signs of the active phase of the MJO. The first place we're going to look is using the TAO buoy array. And when I say the active phase, we're talking over the Pacific. All right. This is data from the TAO buoy array, a series of buoys strung across the equator in the Pacific used for monitoring El Nino, but there are wind sensors on those buoys. We look at the average winds. So this is 5-day average winds. Trades from the east, pretty light in the East Pacific. This is the East Pacific here, West Pacific here. That's the equator. Dateline is right there. That is Papua New Guinea right there. So trades moderately east in the East Pacific, building a little over the Central Pacific, and maybe a little bit stronger here over the West Pacific. But it is not the actual wind speeds that matter. It is the difference from normal for this time of year. And if you do that, look at the arrows here in the East Pacific, and well, there's a couple of arrows actually out of the west there. They're pretty much dead, so this is neutral here. Neutral over the Central Pacific, stronger than a little bit stronger than normal in the West Pacific. So this looks like, I can't tell what the MJO is doing. If anything here, it kind of looks pretty much normal. If anything, maybe weak inactive here in the West Pacific. Let's go look at the forecast. Here we go, 850 millibar zonal wind anomalies. The difference from normal. Now at 850 millibars, that's up about 4,700 feet, but it's a good proxy for what's going on at the ocean surface. This is the whole planet on one chart. So the Pacific, oh, here we go. Pacific starts at about 80 west here. This, you can actually see a seam in the image here. This would be like where Ecuador is. The far west Pacific, New Guinea is like at 125 east, so right there. This is past performance here. This is the future. Purples, blues are easterly anomalies. One could say the inactive phase of the MJO. Reds, oranges, yellows, active phase, westerly anomalies. So back in February, you see active phase somewhere here south of California, but just the thing that really sticks out is these persistent easterly anomalies pretty much right over the date line. That looks like a long ongoing inactive phase of the MJO, but really what it is the La Nina, if you will, the inactive phase of the ENSO cycle, all right? Persistent easterly anomalies is the hallmark of La Nina right over the date line. We've been watching this like a hawk because, as you see here, easterly anomalies finally are forecast to fade about a week from now, maybe 9 days. Yes, weak easterly anomalies after that, but this persistent pattern of nuking easterly anomalies is to fade. And notice the westerly winds, the westerly anomalies that have been like locked over the maritime continent all winter are finally forecast to start easing east, making it about halfway into the West Pacific, the Kelvin wave generation area. That's meaningful when we start talking about the development of El Nino. We are not there yet, but westerly anomalies over the West Pacific, so there's the date line. If they're halfway from New Guinea into the date line, that's a good sign. That suggests the demise of La Nina. So originally we thought the collapse of easterly anomalies was going to be back around March 24th. We're about a week past that now. And by that, I'm talking 2 months ago. Now we're talking, April 7th, let's say. 2 weeks difference for a model that we were back 2 months out. That's actually pretty good. Still lingering easterly anomalies, but the bulk of La Nina just looks like it's going to die in about a week and a couple of days. Let's keep digging. Next up, outgoing and long wave radiation. These models go out 2 weeks. So another view on this. Outgoing long wave radiation. Just fancy words for cloud cover. If you have more cloud cover than normal, well, if the active phase of the MJO is rising air, taking warm, moist air aloft, it's going to hit cold air up in the atmosphere. That cold air will condense and create clouds. So this shows you the blues, cloudier than normal skies, the orange, drier conditions. So this could roughly be the active phase of the MJO, and that's the inactive phase. And let's get ourselves oriented. South America, Central America, Hawaii, New Guinea, equator right there, EQ, date line 180 west right there. So active phase starting to set up in the West Pacific, holding 5 days from now, holding 10 days from now, then collapsing according to the statistic model 15 days from now, so 2 weeks out. The dynamic model, though, the GEFS model suggests active phase weekly holding, if anything, building 2 weeks from now. So let's see if we can, there's the statistic model, final frame of the model. There is the dynamic model. So a big difference between the two models. Let's go look at phase diagrams. These are the details for those two models. The statistic model there, the dynamic model there. How do you read this? Well, the MJO moves from west to east, from the Indian Ocean over the maritime continent to the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot, you can barely see it, is somewhere like maybe right there. That's where the active phase of the MJO is. The further that dot is outside of this circle, the stronger it is. So a very weak active MJO, forecast moving roughly to Africa 2 weeks from today. For the statistic model, the dynamic model has it just meandering around somewhere here in between the West and East Pacific. Again, still really weak, but holding in the Pacific for the next 2 weeks. Let's keep digging. This is the upper level model again, potential for precipitation, sort of like outgoing long wave radiation. South America there, Central America there, New Guinea there, 0 is the equator. Date line runs right down the middle here. This model, statistic model, goes out 40 days, 5 days, each panel, 8 different panels. So you see active phase building over the maritime continent. This is upper level, up at like Jetstream level. So it's about a week ahead of what's going on at the surface. So you see active phase slowly building, pushing its way across the West Pacific into about the 19th of April. That'd really be almost the end of April, considering it's upper level. Then after that, you see the dry air, the oranges, working its way across the Pacific as we get into late April and early May. So I would say this April time frame is probably going to be still decent in terms of MJO support for storm and swell production, be it in the northern hemisphere or the southern hemisphere. Now let's go look at the CFS model. This is a long-range model. It is a dynamic model. This is 850 millibar zonal wind anomalies. Again, the east-west component of the wind. The blues, easterly anomalies, basically synonymous with the inactive phase of the MJO. The reds, westerly anomalies, indicative of the active phase of the MJO. But we have the actual MJO indicator here, the black contour. Dotted means inactive, solid means active. So inactive phases, and this is the whole plan on one chart. So the date line runs right up the middle here. Okay, West Pacific starts at 125 east, so roughly there. So notice, the real thing to notice here is easterly anomalies, and then you get about a week from now, and those easterly anomalies are all but gone. 2 weeks from now, they're completely gone. We're dead neutral as we get into late April. Inactive phase is gone. We were hoping this active phase would be stronger, but the latest forecast, at least per this one. Now, I think the way this model is calibrated, it's got to be a really strong active phase or inactive phase to show up. But you see westerly anomalies encroaching into the West Pacific. Well, they started to here about a week ago. They've backed off just recently, but they're supposed to be back here in the next couple of days. You see the line. You could literally draw a line with the westerly anomalies, making it halfway into the Kelvin wave generation area by the end of the model run, April 26, and easterly anomalies for the first time in the entire winter completely gone, and westerly anomalies starting to develop on the date line. This is what we've been waiting for. And then finally, the CFS model going out 3 months. Past performance is down here, the forecast up here. This paints the same picture. The date line runs right up the middle, far West Pacific, about 125 east, so right up that line. You can see easterly anomalies, November, December, January, February, March. This suggests 1 week from now, the bulk of the easterly anomalies are gone. One last little pocket into 2 weeks from now. Westerly anomalies already in the far West Pacific, building steadily to the east, and then filling the Kelvin wave generation area for the first time in a year. And what's really interesting, every model run keeps showing this strong westerly wind burst building in June. Now, I don't believe a model going out more than about 4 days, much less a week, much less in this case 3 months, but it is a good tease. And this model seems to have a pretty good handle on stuff most of the time. That said, we're in the spring unpredictability barrier, that time from about March 1st to about June 1st, where the models really don't have a good handle on things. But it is a nice tease, if nothing else. All right, let's overlay the MJO. All right, here's our current active phase of the MJO, already pushing, not to the date line yet. Date line's roughly there, but give it about a week, it's going to be to the date line, maybe a week and a half. Westerly anomalies, forecast taking over and in control. Pretty much from there on, the big active phase in June is the magic kind of. We'll see if that really happens. But let's overlay the low pass filter. This is the low pressure, high pressure bias. The dotted contour, high pressure, the solid contour, low pressure. Notice this is our La Nina signal. 1, 2, 3 contours. It's been in place since the beginning of January. The third contour is supposed to fade out about 2 weeks from now. The second contour as we get into the first week of May. And then notice the high pressure bias. Well, where's the date line? Roughly right about there. Completely east of even the date line by mid-May. So this suggests La Nina fading on the date line, moving out to the East Pacific. And see the low pressure bias here? We want this in the Pacific. It's finally going to start making some headroads in about the end of April, I'd say, and then moving in earnest as we get to the beginning of May. By the June timeframe, the low pressure bias is reaching, if not beyond the date line, and building strong. This suggests at least a neutral pattern setting up, if not something better. This is kind of an interesting tease. All right, so let's go look now at El Nino, La Nina, and the ENSO pattern. What's going on? We're going to start by looking at subsurface water temperature anomalies. Data from the TAO buoy array. Again, West Pacific here, East Pacific here. These are the anchor lines on the buoys. The X's are individual sensors. The sensors collect temperature data, use a model to fill in the gaps, and you get a picture of where's the balance of east or warm or cold water. Remember, if trades are stronger than normal, driven by inactive phases of the MJO, they take warm water, typically in the east, and push it west. We've been under La Nina, inactive phase of the MJO, no big surprise. The 28-degree isotherm here is over in the far west Pacific. Now, the interesting thing is, last week it was at like 172 or 173. Now it's at 176, pushing to 177, suggesting winds are dying over here and warm water is trying to push to the east. The 24-degree isotherm goes the whole way across the Pacific. Oh, look at that. A little flavor of 28-degree isotherm. This is centigrade. Temperature's 28 degrees centigrade, building over in the East Pacific, suggesting perhaps trades are dying, allowing warm water, or if nothing else, the sun to cook the water and start warming it. Still pretty shallow here, the depth of the 24-degree isotherm. Still pretty shallow in the east, but suggest perhaps an improving pattern. Now, it is not the actual temperatures that matter as much as the anomalies. Here they are. Plus 2-degree anomalies in the West Pacific, plus 2-degree anomalies in the East Pacific. The last bit of our La Nina cool pool sitting here in two lobes, minus 2 degrees centigrade, and working their way to the surface. But this warm pool here, this suggests a building warm pool in the east. Let's go look at another model. This is the same data, but then enhanced with satellite data. This shows that building warm pool in the east. Not even sure that this really exists here, but really it's warm, and look at the building tongue here. It still only goes to about 165 west, but a building warm pool, building warm anomalies in the east, the last of La Nina cut off and just hanging here somewhere over the central Pacific. Here is the sea level anomaly data. There's Florida, there is Mexico, Central America, we go down. There's the equator right there, dateline right there, New Guinea over there, Ecuador there, going down to Peru and Chile. It is only 5 degrees north and south of the equator that we really care about. The real interesting thing here is, now these are not temperatures. This is a satellite measuring the height of the sphere of the ocean. Specifically, is it higher or lower than normal? Lower than normal sphere heights suggest cold water at depth. Cold water contracts, you get a divot on the ocean surface. Whoop, there we go, divot. Warm water at depth expands, it'll push your ocean surface up. And by up, we're talking 5 or 10 centimeters. I mean, like that much. But the satellite's really sensitive. It can see that. So notice off of Ecuador and the Galapagos here, positive heights. Let's look at our scale. Very little, but like 0 to 5 centimeters above normal over the Galapagos the whole way out and building. This suggests that this correlates with that warm subsurface pool we saw building. The last of La Nina, Modoki La Nina, right out here somewhere. Where is that? 158. So there's Hawaii, south of Hawaii. Minus 20 centimeters, minus 15 centimeters here. But, you know, really close on the equator, it's 10 centimeters. So this is where the bulk of the remaining cool pool is. I think it's getting pressure here from the east, and there's warm water in the west. It's getting squeezed. It doesn't have much hope. Here is upper ocean heat anomalies over the past year. West Pacific here, East Pacific here. We're going back a year, April of 2024. Cold, the blues, colder than normal temperatures, in control of the East Pacific. 1, 2, 3, 4, 5 pulses. There was actually another one before that. So this is 6 pulses. But then now here you see, as of March, notice the building warm pool in the west, building warm pool now in the east, the last little finger of the cool anomalies at 160 west and fading. It looks like there is no hope for La Nina. Thank goodness. All right, all that subsurface temperature info is great, but it really takes the temperature change occurring at the ocean's surface, right? So these are sea surface temperature anomalies, difference from normal for this time of year. South America, Central America, Australia, New Guinea, equator right there, dateline right there. 5 degrees north and south of the equator. That's all that really matters in terms of ENSO and the MJO and all this stuff. The real thing to notice here, look at this building warm pool off of Ecuador out to the Galapagos, and now the whole way out to almost 130 west. Here is your La Nina cool pool right here. There were darker cool spots in here all winter. They are now fading. You see interspersed warm spots. This cool pool slowly degrading. Now you see cool water coming off of California. It is springtime. High pressure building in the Gulf of Alaska, creating northwest winds. That explains all that. And then that pattern just sort of comes down, feeds into the residual Modoki La Nina cool pool out here over the central Pacific. But the warm water here, that really is an indicator that La Nina, whatever is left of it, is certainly fading. Let's go look at the change over the past 7 days. Again, it is 5 degrees north and south of the equator that really matter. Ecuador here, there's the equator. Galapagos there. You see building warm temperatures along Peru, along Ecuador and coming up from Peru. A little bit of cool here east of the Galapagos. Another little slightly cooling temperatures south of California. But out here where the Modoki warm cool pool is biggest, you see building warm temperatures over the entire area. So it seems, at least for the moment, that La Nina is trying to hold on, but looking at everything, it really doesn't have a whole lot of a chance, and odds of it rebuilding seem weak at this moment in time. Sea surface temperature trend in the Nino 1.2 region. This is the area right there by the Galapagos and Ecuador. Temperatures were up to 1.5 degrees above normal. There's neutral right there. They fell off last week a little bit. Rebuilding today, 845 thousandths of a degree, so more than 3/4 of a degree above normal. So a building warm pattern in the East Pacific. The official El Nino monitoring region, the Nino 3.4 region, the area from on the equator, 5 degrees north and south of the equator from points south of California, about 120 west out to 170 west, almost to the dateline, Temperatures today, oh, we'll expose it right there, 323 thousandths of a degree below normal. So not officially neutral, but let's put things in terms of something we can relate to. Neutral, from an ENSO standpoint, neutral is plus half a degree to minus half a degree. So we've been there since about the beginning of March, neutral. Half a degree to 1 degree is weak La Nina. 1 degree to 1.5 degrees is moderate La Nina. We never even got there. And this is raw data. It's not corrected for a warming plant and all that. But all this is saying is we are dead neutral as of right now. Let's keep going. Corrected sea surface temperature anomalies for the Nino 3.4 region right here, minus 1/10 of a degree. The inactive phase of the MJO was pushing over and probably still is pushing over the East Pacific, and that created a little hit. You see we had negative temperatures there, warming, warming, warming. Inactive phase pushing over the East Pacific while the active phase of the MJO is building over the West Pacific. We knew temperatures would take a bit of a hit. And this is back March 19th. We're already now practically into April. So we're going to see this maybe go negative for 1 more week, and then temperatures probably will move up from there. Then finally, what does the atmosphere think is going on? All right, we have data from Tahiti, sea surface, actual air pressure data from Tahiti and Darwin. When pressure is lower in Tahiti, higher over Darwin, the index goes negative. When pressure is higher over Tahiti, lower over Darwin, the index goes positive. So today's value plus 14.41, suggesting La Nina pattern. Look back for the past month. It's been positive, if anything, rising a little bit. The 30-day average takes some of the noise out of this, though. Today's value plus 7.93. Where were we a month ago? 0.8. So pretty much dead neutral. Not really surprising. The 90-day average is your La Nina El Nino indicator. Today's value 5.47 positive. Where were we a month ago? 6.32. So pretty much holding steady. We're on the cusp. Let's look at this data in a graph. Maybe that'll help illustrate it better. So here's the 30-day running average of the Southern Oscillation Index. Here was our El Nino, weak as can be. This is the low normal range. This is the high normal range. Here's our weak El Nino back in November 23 time frame, 23, 24. Then we went into La Nina, or the Modoki La Nina, but you see, again, it was all mostly dead neutral up until about February, and even then, well, December and February, or January and February, still toggling between weekly, you see the pushes in the MJO here, but roughly bare borderline La Nina territory. The downward spikes are the active phase of the MJO, the upward spikes are the inactive phase. This is picking up the last inactive phase that pushed through the Pacific. I expect to see this starting to turn down as the active phase builds over into the West Pacific here in the coming 2 weeks. And then finally, sea surface temperature anomaly forecast for the Nino 3.4 region, the official El Nino monitoring region. So April 15th, that's there. The latest, or the March 15th actual data came in way better than expected. It was supposed to be down here. It came in positive at like 1/4 of a degree. Temperatures forecast in the ocean falling to, it was down almost at 1/2 degree last week. Now the model goes, no, maybe have 1/4 of a degree in mid-April. And then after that, we're off to the races. And just in the past couple of days, look at this. If you go way out, it shows temperatures up to 3/4 of a degree above normal. As we get into December, that would be like bordering on weak El Nino conditions. I don't believe it. Let's go look at this other model. This is the same model, but PDF corrected. It's basically saying the exact same thing, suggesting at least a return to neutral, if not neutral biased warm as we get into the fall. This is very good news. So for right now, We're looking at weather pushing into California, snow for the Sierra, and rain down even into Southern California, though it's probably going to be more on the order of spring showers. And same deal up in the mountains, not like massive accumulations of snow, but probably the last shot at real snow for the Sierra for the season, and the last shot of any meaningful rain over most of California for the season. After that, I expect high pressure to start building, northwest winds along the coast, water temperatures dropping. It's going to be really interesting to see exactly how strong high pressure builds and how long it lasts. The weaker the northwest wind event over the next through April and May, the better. That suggests the weaker the La Nina pattern, regardless of the what all the models tell you. If you're a surfer and you're on the coast, water temperatures and northwest winds in California are a good, or in trades in Hawaii are a real good indicator of whether pressure in the Pacific is higher or lower than normal. Higher than normal pressure means more wind. Lower than normal pressure means less wind. So we'll keep our eye on that. Okay, but looking at all the model data, it suggests, well, all right, northern hemi, one last gale, pretty broad one theoretically, targeting Hawaii well as we get into the latter part of the work week, with swell into the islands potentially for next weekend, maybe some sideband energy for California, but I'm not holding my breath. Of more interest is the southern hemi appears to be trying to come online with multiple, I'll call them background southern hemi swells. Yeah, surf heights, maybe chest high at top spots kind of thing. But it appears summer is trying to come online down south and the North Pacific. One last push, one last surprise or something like that. Yeah, one last winter surprise is happening or scheduled to happen this week, and then we probably fall into a hard spring pattern after that. Looking long term, models looking most encouraging. The complete demise of La Nina is expected somewhere in the next week to week and a half. Hopefully by next week when we do this video, I'll have good news to tell you and we can put a fork in it and call it done. But if not, maybe it'll linger for another week. Looking long term though, a return to ENSO neutral seems highly likely, and maybe something a little bit better than that, though I'm not holding my breath. So next fall, winter, looking to be theoretically a normal season. Bring it on. We'll take it. All right, that's the video for this week. If you enjoyed it, give us a thumbs up. If you have comments or questions, write it up down below. If you haven't subscribed, please do subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. And, of course, if you'd like to make a contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We will see you again next week. Same time, same channel. Thanks so much for watching.